It started just like that. Hey, Rod.
Hey,
Hey, Dilyana.
Hello.
everyone on the call
Where?
has glasses. This is a first for me here.
Oh, yeah. And these are glasses. I'm not wearing sunglasses. I just got tinted glasses. And it snowed today, so there's no school. It's like if you took confectioner sugar and a sieve and shook it on the ground, that's how much snow we got. So we haven't converted to cannibalism yet. Probably going to be okay.
No, but I'm sure that all the stores are out of bread and eggs.
Bread, eggs, and tissue paper.
That's right.
Um, Rod, could you introduce yourself again,
Oh, absolutely.
please? Yeah.
Director of Corporate Development here at Chaos. A lot of different responsibilities, but one of them is finding out new product opportunities and essentially bringing them to life in our portfolio. And Impact is a great example of that. It's one where we talk to a lot of customers about their biggest problems. Building performance and modeling building performance came up repeatedly. And so
Right.
it started down a long road. And so there you go.
Here we are. This is the first pass.
Yeah,
Hello,
exactly.
Dilyana. Could you introduce yourself and explain your role in the creation of impact?
Hello. I am part of the product management team at Chaos, and Enscape Impact is my responsibility, meaning that I get to do the discoveries and gather feedback and plan improvements.
Perfect. So when people are in the forums talking about impact, you're probably going to be lurking there as well
Yeah, I look at those from time to time.
from time to time. And where are you located?
And Sophia,
Bulgaria.
yeah.
Well, we won't keep you up too long. Thank you. So this is the file. I'm just going to bring us quickly back up to speed. This is a file that we had the last time. And what I learned the hard way was that we don't need all of this visual stuff in order to get an accurate result. So the first thing we did was go to model categories, select everything, and turn everything off because we only need a couple of categories. Things like ceilings, curtain wall stuff, because they contain space, doors, floors. Scrolling down a bit, we don't need furniture. We don't need stairs and railings and ramps, especially railings from the last video. That's one of the things that caught me out. So roofs, and then windows and walls. So we
Yeah,
did all that stuff.
particularly you need things that are part of your building envelope.
The building, so things that contain space. Rod, you
Mm.
mentioned that there's voxels, or Dilyana, you can explain what are these voxels and what is the purpose of them for the creation of this analytic model?
Well, voxels we use to create our geometric model because we detect the geometry ourselves. We do not depend on the host application, for this example, Revit. So the way we detect it is like we fill in the empty space with, let's call boxes that are 35
Right.
by 35 centimeters.
And then that's used to identify not
Okay.
only the shape of the volume, but also helps us identify all of the openings, the windows and things like that. What
Right.
you found in your previous model, Phil, is that by including all of this sort of indoor outdoor spaces, which looks lovely in the model, by the way,
Yeah, but
it
like this
included that
roof over the
as
dock, that's going to throw stuff off. Like
exactly. And
that's,
so you ended up essentially creating rooms that were part of your energy model that weren't, in fact, rooms.
yeah, these little spaces like this outbuilding down here and this little outdoor shower, don't need it. Don't need it. Not important. So what I ended up doing was grabbing like that little structural piece just to get a section box around what we really care about. And then this roof. And I'm going to grab the section box and it just isolates the project thusly. And I want to use this as a starting point and then do an energy analysis with a very constrained one because it's slightly different and you guys can explain, why it's different. So I'm going to jump over to Enscape and start. And we're just starting from scratch. Nothing was pre-baked for this. We're just doing it live. Doesn't take very long to open Enscape. And it's going to have to, when we go to the energy analysis tool, it's going to think a little bit again. But it only has to think about what's in the view. So to your point, Dilyana, Enscape, I don't have to put R values in this. I don't have to assign something as a wall if I'm using SketchUp. It's just making assumptions based on contained space.
Well, yes, and also it is based on the building type and so on that we're going to see in a bit,
Yeah.
that you're going to show.
And the new
Why?
button's over here. It's not where it was last week over there. So we're using a preview of what version is this? 4.3?
4.3, yeah.
4.3. And why did you put the button over here?
We put it there on purpose because Impact is different than all of our other
So
functionality.
there's even a line over here.
Yeah.
Like it's yeah. So here's a result. 22.42 megawatt hours a year. And we'll get into the specifics, but I want to show you a little difference here. So I'm just going to zoom in a bit. This is with the decks and roof shown. So kind of freeze that idea in your mind, 22.42, and then go back to Revit. And I'm just going to select this wall. And then the other extents is this wall. And then create another section box just around that piece. Right. So now it's a little bit less, like the roofs have been pulled back. There's no more decks. And it's going to think again for a moment. And then it's going to come up with a number that's slightly less. And why do you think that is? Is it in terms of megawatt hours per year? So, like, I don't know. I would think, like, well, is the heating load going to go down if I have overhangs, or is it going to increase if I don't have overhangs? So, what we're seeing now is the total megawatt hours have decreased slightly
Yeah, by about two or
between,
so.
yeah.
And if you look at what you had before, though, you had the two projections from your roof. So you did
Yep.
lose some condition space that
Do you
was
think
in
it was
there.
the decks and the roofs that was kind
I
of
don't think it was necessarily the decks. I think it was those spaces in the roofs. I mean, those weren't insignificant that you had.
oh,
Those
you
two.
mean the volumes inside of that
Yeah,
roof, so kind of above the deck in that.
in that piece. So if you look at the where you have gray
Yeah.
boxes, sort of these gray
Yeah,
rectangles
that's
right
the
now.
interior wall
Yeah, that's the interior
from
wall,
that.
but those areas I think I won't.
Okay, so it's not thinking about that. Would it be helpful if we visualized those voxels? Could we turn them on so that we could go, oh, like if it got rid of the model and you could see these voxels and you go, oh, wait a minute, there's these voxels poking out in space. Maybe we don't need those. So you
Yeah, we
turn off.
we actually plan this with our next functionality that is going to be thermal comfort. We
Yep.
will visualize what we have detected from the project.
Okay. So that's a future thing, maybe. So let's go through some of these settings. Uh, Location. Is it reading the location from the design file if you've already specified it, or should you still specify it again?
If you have already specified, we will detect it, but you can
Yep.
change it manually if you wish to.
Right. So you're not dependent on having that information in the design file be correct, because maybe we don't know. Is it as far as the orientation of the building in the design file? Like there's no orientation value here. So is it taking its kind of aspect? Is it facing this direction or that direction? Where is that determined?
No, I don't think so. It
Okay.
can take something from the site context, actually, but
Right. So if you have trees or other objects around it that might be shading the building.
no, I mean as a orientation, but no, we don't
Okay.
take into account shading.
Yeah, there's some assumptions here. It kind of reminds me of early Enscape in a way that I showed Enscape to a couple of really big smart firms, and I got feedback once that said, "Oh, we can't use this because it doesn't work with 3D Max." And I went, "Oh, they think Enscape is for wizards. Enscape is for muggles. Enscape is for regular people that just want to see it right now. They don't want to spend a week taking the model offline and making it super precious. It seems to be that the value of this is I want analysis for regular people as early as possible in the design. So how would you frame that, Rod? Like in terms of is this meant to be for a specialist or is it meant to be for like a crowdsource? I've already done the work here. I don't have to open Excel. Let me just get some analytic numbers based on the work I've already done without having to re-input it somewhere.
I mean, I think that's one of there's a couple of pieces there. The first one I'd say is yes, it's intended to be so easy
Mm,
that why aren't you doing it? Because it really is a matter of, well, can you answer those questions you have up on the screen right now. I hope you can.
Right. Yeah,
And if
there's
you
like
can, you're going to get a preliminary result. And that
there's
result is, I mean, it's easy, right? I mean, it's literally, this is something where you don't need to charge an extra fee to run an energy model here. This is
right.
just run a model.
But
Um,
this is not assuming I haven't had to put a lot of like if I'm using generic walls in terms of Revit or if I was using SketchUp, it doesn't know R values of vertical planes.
no,
So there's some
and
assumptions.
this doesn't pull that data regardless anyway, because you're not
Right.
going to even know that early on. So the
No.
idea is that it's a very low threshold data point, but at the same time, and this gets to sort of who's it good for, it still has a high level of accuracy because the underlying analysis engine and the quality of the embedded assumptions that are part of the template file that's all happening behind the scenes are pretty refined. They're coming from IES, which, I mean, when it
Yes.
comes to like people that really know what they're doing, with energy modeling, like that's it. Like they really know what they're doing. So
So they can trust the vector of this. I mean, you guys are hiding a lot of complexity here.
we
At
are,
the
and that's,
moment, there's
yeah.
only 6 building types. I would expect that's going to expand in the future. Like there's no manufacturing as a building type.
No, and I know
Yes,
But
you
we
were
are
asking
adding.
for what were you asking for? Data
a
centers,
data
Phil?
center.
Yeah.
Yep. It
So
came
there,
up because, and you guys answered the question they had. So the data centers have beautiful office space and then a very large data center space, and they needed to like, where's this mix
yeah. How
kind
do
of
you do
building it?
both?
You just
It's
do one and then you do the other. And you
but
guys
it's not a
suggested
perfect
use
solution.
manufacturing.
Yeah.
No,
No,
actually,
but the vector is, I mean, if I would rather have a very good answer today than a allegedly perfect answer in a
But
week.
there's a couple of pieces here though that I want to pick apart that get to like who's it good for. The first one is that you showed a dashboard figure right there, right, and that's a total figure, and I think that one's one where we do run, and Dilyana can expand on this, a fair bit of QA exercises comparing these results to something that's generated via IES, and we're
Right.
seeing really strong alignment there, like single digit agreement amongst a variety of model types and locations and things like that. But what's also really exciting is that you make a change and we're seeing like within like it's like below 1% agreement with the same type of change if you were to do it in the IES sort of engineering grade software. Like you change a window shape in both softwares and you look at the delta, that same delta will appear in both. Right. So that means that as you make
Okay.
decisions, really good. Now this gets to like who's it good for? It's like, well, in all those cases it's being used by the architect. But the person who's really going to benefit is the engineer because they're not going to inherit a problem building that they have to fix. Their building's
Right.
going
Where
to
there were no
be
assumptions and
no
they were
assumptions,
just,
right?
the building was imposed on them. And
Yeah,
they're
you're
like,
like, here,
really?
fix
This is
this, make it code
right.
compliant.
It's too late because by the time, like, even in the rendering, the visual rendering space, in my own practical experience, we would show the customer the plans, the elevations, the sections, and then we get to the very end once those are calcified, and we show them renderings. And they go, "Oh, this isn't right." And I'm thinking, "But we just showed you plans, elevations, and sections." So the ability to just see it concurrent to the design and then not impose a surprise on the engineer to figure it out, it just seems like a no-brainer.
It seems like a no-brainer, and plus, if you're trying to convince a client to make a certain design decision, right, they're going to wonder, well, how does it look? How much does it cost? And
Right.
how does it perform? And if you're telling them these three pieces of information, sort of in a disconnected conversation,
Right.
that's not going to make a very compelling argument. So now you can show them, hey, this is how it looks, this is how it performs, and that's all part of the same visual package.
So if we go back to these Enscape settings, we have 6 building types now. And Diliana, you were saying that these are going to increase in the future. We're
yes,
not
pretty soon.
limited to this.
Yeah.
Any
Mm.
ideas of what might come next?
We'll have industrial, we'll have sports as well. We'll have hospitality, for
Oh,
example.
okay.
Yeah.
Excellent. With the build year, okay, so there's a build year and there's a renovation year. If you don't have a renovation, this is just a new building. You don't have to choose anything here. You don't choose the same number twice. You leave that blank. Okay.
Definitely.
And then when we go over to the dashboard, can you walk us through? Let's just go left to right, top to bottom. Peak, what does that mean? Peak heating loads.
Well, peak load actually means this is the maximum amount of energy that your building will require for heating and for cooling. This is in the worst climate conditions that can happen at your location. This data is based on historical data. Uh,
This is peak load, not over an amount of time, but peak load
It's
in an instance.
instantaneous.
yeah, and
Okay.
you
Okay.
don't have them simultaneously.
Yeah.
Right, right, right. Yeah, I get it. Except I know someone in my household, they love to run the heat so hot that the air conditioning kicks on. Might throw
Yeah.
off the
Well,
numbers.
yeah, I think
So
anyone
in
who's
effect,
designed buildings knows that there's often windows open and heating full blast happening at the same
right,
time.
because that cold breeze when the heat gets too stifling is so nice. Just
Yeah, it's expensive but nice. Yeah.
yeah. Okay, so this is peak loads at any given time is anticipated here for heating and
I
cooling.
mean, it's not at any given time; it's when they occur. But yes,
Yes,
Right.
this is
but
the
that
worst
during the
It's
course of
not
the
an
year, that
average
is your
over a
no,
unit of time.
case.
It's a peak.
yeah,
It's the highest amount.
that you'll get on an annual basis.
Yeah, this
Okay.
helps you plan for the plant supplying your building.
Okay. So the likely required mechanical intervention to mitigate peak heat and peak load.
You
You
need
get
Give you
them
a
that
all
sense of
energy.
plugged.
sizing and things like
Yeah,
that.
you want to
Yeah.
plan for the size that you can count on.
Right. Well, I don't. I would work with an engineer, but after the building's settled down and they go, really? That's what we're supposed to do now? Because we have to make these changes to accommodate that. But this is giving it this is giving it an answer in moments, concurrent to the design. So total carbon emission, Dilyana, what does that mean?
Well, this speaks of the carbon footprint your building is going to have during operations. And for some buildings, this is really important as the aim is for sustainability and lowest possible carbon footprint.
So this number, if you're trying to keep it low, do we know a range? Like for some of these low, moderate, high, for the size of this building, for its location, is that a likely range, or this is just the value
Unfortunately,
per year?
unfortunately, there is no benchmarking data currently, meaning we have no statistics for other buildings. Therefore, we're just showing the project one.
So this is
Yeah,
operational carbon per
it
year.
is, and that's part of the reason
Okay.
why there's no hard benchmark there. Is that this is going to vary quite a bit by your location. It's tied to your grid and what your grid carbon intensity is, and so depending upon if you have, say, more renewable energy or you have more non-renewable energy in your grid, then that figure is going to change. So you may actually be consuming less energy than a building elsewhere, but your grid's particularly dirty, so that figure will be
Gotcha.
higher.
With energy use intensity, it's giving this low, moderate, high value. Where is this coming from? This is an area
This particularly, we are benchmarking to similar project to the users one. We are comparing.
for the building type. Like, is it looking
Yeah,
at single family of this size? Okay.
yes, yes. And that's why we can tell you if your result is good or not that good.
And if this project was showing moderate or high, what are some of the things a user could do to mitigate and reduce the energy use intensity?
Well, for this we have to reduce the energy required. As particular measures, we could, for example, rotate the building so it's better exposed to sunlight, so it
Okay.
wouldn't need that much heating. But it really depends on. It's complex. It depends on the location and meaning the climate, whether you need more heating or more cooling. And that's a nice thing to see with our performance maps, because there you can notice whether the rooms are and require much energy for heating or for cooling.
If there's a lot of open glass glazing areas and we reduce those, would you expect that energy use intensity to decrease?
Yeah, it should.
Okay. And then the end use, cooling, hot water, lighting, equipment, space heating. And I like the way it's just spelled out, and you guys have done a nice job here just to kind of highlight it as you roll over them. It's just a little usability thing. Um, But this is looking at the main operational factors for the building. So I guess cooling, hot water. I didn't realize hot water is such an impact for this particular building type. Maybe if you get into office space, hot water is not as intense, but
Yes.
for residential projects, it is. There's only five values here. Are there other values that, I mean, there could be a lot of values here, but they're not as, if we're going to keep this really simple and approachable, these are the main values, or are there other things that we might reveal in the future?
So these are the ones we considered from the templates as more
Okay.
important.
And anything, I mean, does this look like it's kind of operationally in line with what you'd expect for kind of the building configuration, the building shape? I mean, we're in line with hot water. Like, how would it know that hot water, is it making some assumptions based on on unit area and likely occupancy?
Yes,
Okay.
it's related to occupancy that is defined in the template.
Okay, so single family has a certain occupancy value for the, are those regionally specific? Like, would you, if you went to Australia, New Zealand, Singapore, is it different occupancy in those areas by unit?
No, I don't.
Okay,
Now, other aspects of the template do vary depending upon where you're located, but occupancy would not.
right, right. No, my, yeah.
But
Okay, good to know. And
later
then when we
this
get,
year, we plan to allow users to modify these, so it will
oh,
be.
they could input values for occupancy of unit area or,
Yeah. Because right now the
yeah,
template
there's,
sort of behind the scenes is under the hood. We do provide an example in our knowledge base so people can understand what factors are in it. But what we want to be able to do is daylight it so the user says, I know something's different here. And so they can edit that component of it. Not all components of the template will probably be, at least initially, open to be edited. But
right,
those that are, say, more nuanced or more likely to vary from project to project, and also fairly self-explanatory. People can easily understand what it means, like occupancy or say opening and closing, that kind of thing. Would be something we would allow for people to
so you can
adjust to.
make an assumption if you're making an assumption based on unit area and you're saying, okay, occupancy is likely going to be in this range, but as a designer, if I know my client that this is going to be a show home for a client and it's just grandmother and grandfather
Yeah.
with periodic visitors, you could set the occupancy to three or two,
Exactly.
and it's
Yeah.
going to drop the
Yeah.
energy
And you could do
values.
like say, the hours of operation for a building if you happen to know that it's at a certain time, or maybe it's 24-hour building or something like that. You can adjust it appropriately beyond
Okay.
what's in the template.
Yeah, but it's a beautiful start because it's approachable. As long as you give it the right information. You said, if you get the right information in, simplify what has to be calculated, you're going to get a good vector.
Exactly. And this is just about giving a bit more refinement. I think that's the idea. Is you want to throw the dart and get it somewhere on the board to start with, and then you can
Let's start on the board,
let's
right?
get on the
Just hit the
board, right?
board.
And then you can start refining it a bit more, and that's where this idea of the
Do
the
we
template come in.
do we
Comes in.
really need two nines of accuracy here? Is that or
Well,
You
because it's
That's what's interesting
megabytes.
here is
why not three nines of
well,
accuracy?
I
I
think
don't
part of
know.
it
It's
though is it's funny because when you look at the total figure in isolation, you're like, why do you bother to do that? But I
right,
will tell you that if you change an aspect of your design and you compare run A versus run B, we
right.
are getting to that level of accuracy. That's the part where you need it there. Do you need the point something? Well, Dilyana, that's a good question. Probably not.
I mean, if you're
Um,
jumping up 1,000 kilowatt hours, it
yeah,
probably
the kill.
makes a
Yeah,
big difference. But maybe one nine or it's there. You guys are calculating it, showing it. I think if it was three or four, it might raise my eyebrow. I'd go,
We also
I don't
have more numbers actually in the back.
know. Want to see nine nines of accuracy.
yeah. See how there's not much differentiation, which is kind of surprising. Um,
Do you think that's based on the location or
Yeah, could be. I don't know if that location particularly requires a lot of cooling.
I would say it is more cooling for that region. But I mean,
yeah,
actually, North Carolina, it's kind of
But his peak loads is different than annual, right? I guess that's the. But that was, if you do look at the energy by end use,
Okay.
actually, your cooling's quite modest there. I mean, surprisingly so, frankly. I mean, it's. I like the idea of energy analysis, define expectations, because if you knew all the answers, why bother? But I still
Right.
will admit I'm surprised.
Well, could it be that the energy intensity of cooling is negligible compared to the energy intensity of heating for those areas?
No, I don't think these
Okay.
are related. It's these are related to the patterns. There is for us, cooling and heating are constantly set on, and
Right.
we have a point where we trigger the heating and the cooling. And I think the cooling was at 23 degrees, meaning that if you're only if the climate is above 23 degrees, the cooling will be on. So
Oh, and
that's why
that's
I
not going to
say
be very impactful for that region. Okay. And so
that's what I meant.
if the temperature is, if you're trying to move between, let's say, 30 degrees centigrade and 23 degrees, that's not as much of a temperature swing if I'm trying to bring it from, well, today is 0 degrees centigrade up to 23. Could that be the difference?
Yeah, for heating, the set point, I think it was 21 degrees.
Right.
It's a pretty
Okay.
narrow band
Yeah,
then,
but
where you don't need any conditioning.
the
But this kind of
difference,
gets to a little bit of that template file
okay.
access, though, that I think is really key. Because say, oh, I know that this person loves to wear a sweater and is really cheap in the winter, so they're going to have that set point nice and low. Then you could
Right.
potentially do that.
And also
No,
in
I think
some,
the way you explain it with the temperature variant to get it to a certain cool, a certain low temperature during summer months is not as extreme as a temperature variant in winter months.
Definitely, right? If you look at the delta, I mean, right now where I'm at, it's probably about 12 degrees Fahrenheit, right? And our set point is 64 or something like that, right? So
Right.
that's a massive jump that you're having to make there, right? You're jumping up 50 some
For
odd
heating.
degrees
And
for
that's why we're
heating,
seeing a peak
right? And then,
load
yeah,
for
and
heating
even
is
in the
higher.
worst conditions for cooling, I may be going from 100 down to 75 or something like that, or 72 or something,
Okay.
significantly less.
With regard, so the average energy used for heating and cooling, what are we seeing here as opposed to what was being visualized in peak loads?
well, the peak load is the most severe condition, meaning that this could be like 1 day per year only, or
Right.
something like that.
And
Well,
this is more of an average.
yeah, this is for the whole year.
Okay. And then the last one is thermal gains, solar thermal gains. Let me go back. I'm going to change this to heating. I don't know if I see where the differences are. What is this visualizing?
Solar gains, this means how much thermal energy from the sun your building is going to get, and is dependent again on the location. We do not take into account the site context though.
What about the overhangs? The overhangs that we had at the beginning. Would the roof overhangs decrease the solar gains? Would it be better from a standpoint to keep those on, even though it's going to cause a false calculation with regard to those spaces, the volume inside the roof? Or is there a way to model it in the design tools so that they don't get calculated somehow?
Not yet, we do not detect shading elements so far.
You don't detect them. So the roof
Oh,
overhang over the decks really wouldn't make a difference if we had them turned on or not.
no, when we have daylight comfort, then we'll have developed this functionality.
Okay, so that brings us into what's coming next. What kind of things are coming in the future?
And actually, that brings to mind a question because I know some of the things, believe it or not, Phil,
Yeah,
that are coming.
I believe
And
it.
yeah, believe it or not, one of them is around comfort, but comfort is highly dependent upon what's happening in a space. So let's say it's a space where it's an office, people are primarily sedentary, the clothing value that they wear is known to be higher versus, say, like a gym where your metabolic rate and activity is going to be significantly higher, but the
Okay.
amount of clothing that you're wearing is going to be less. Right. So you need to know what's happening in a given space. Those are sort of two extreme examples that may not be necessarily reflected here. But part of that means then is that you can apply a particular function to a given space that is identified via that voxel-based methodology we talked about initially.
Okay, so the idea is that right now I'm not doing anything in the
Yeah, and
design
that
file
gets
to
to kind of a
identify the
little bit of
space.
this, right? You look at this and you're like, well, kind of a mix. But what you're seeing is that it's applying a combined sort of average template over the course of your whole building. So whether something's a kitchen or it's a bedroom, it doesn't matter in this case. It's all just an averaged
An overall
utilize
average.
average and average for like, hey, this is house, and it's kind of a combination of all those. It's kind of like putting all the uses of a house into a blender and mixing it up and then sprinkling it over. But with this new methodology, there will be some nuance in there, which I think is actually really exciting because it does matter what's happening in a given space as you want to increase that level of accuracy.
And this way,
Yeah.
mixed type buildings will be achieved.
Okay, so you have one building overall, but identify the spaces per use, and then you don't have to do separate calculations for pieces of buildings.
Yeah, definitely. You can have the restaurant at the first floor and the offices above.
Oh, okay. And you're just designating the use, and it will make calculations based on those assumptions.
Yeah, it will.
Look, this has been great, and I really appreciate you guys walking through this, making it understandable in human terms. And I'm looking forward to the next release, which I don't even know what it is. But do you think there will be changes from what we've seen here in 4.3,
Uh,
like additional building types or anything?
this is actually 4.3, the
Yeah.
preview version.
Okay.
And probably in 4.4, we'll have the additional building types.
Excellent. All right. Anything else, Rod? Any other thoughts or important points?
No, honestly, I think just if there's anything, any one takeaway is that you can see how
Yep.
easy it is to use. Like, this
Yeah.
is not intended to be
Great.
intimidating. And I think that's one of the big pieces here is we really just want people to get their hands on it and start experimenting.
Look, the big piece for me is just this big end use number here. That just gives me a vector really quickly. And then the peak loads really quickly, and just put an engineer on a vector and say, this is based on what we have today. We've just started the massing study.
Oh, definitely. And I would also really
We're on.
encourage people to explore. Change the size of your
Okay.
windows, change the location of the windows, and look at the delta between these various runs, because that's where impact really
Okay.
sings when it comes to the quality of the analysis that
You
it's
talk about
generating.
reducing glazing,
Yeah,
changing this,
reducing the glazing, reducing the
right?
or altering
Openings and
openings,
The height
dimensions
of
of your
the
overall
rooms.
building, your massing, all of that stuff.
what were you saying, Dilyana? Something
The,
the
the heights of the rooms also.
Oh, okay, because that's going to decrease your volume that needs to be calculated.
Yeah,
Yes.
it needs to be conditioned. Yeah.
Okay. Anything else, Dilyana?
I don't know. Just try it out and see how your variants compete to one another because you're always winning.
Thank you very much, you guys. Appreciate it. Stay warm. Good night. Have a good day. Take care.
Thank you.